we'll be talking about drivers and hotspots of extinction risk in marine mammals by Davidson et al. So a little introduction. Oceans occupy 71% of the Earth's surface, and right now human activities are polluting it. And a little picture of a seal over there with some fishing gear on it, and then trash in the ocean, and styrofoam, and then oil spills are another reason, or another way that we are polluting it. We're also warming the atmosphere, which then warms the ocean, so we're acidifying it, essentially, which means that we're bleaching all these corals and changing the pH. We're also melting sea ice, again with the warming of the atmosphere, and this is affecting northern species like polar bears and walruses. Stephanie kind of covered it. We're also over-harvesting fisheries, so this is a little graph. I don't really want to go too much in depth of it, but it's fishing, and then it's talking about harvest mortality, physical impact of fishing gear, and bycatch, so 3 things that overfishing is doing. And, wrong one. Okay, so basically we're altering entire food webs. In the paper it says that 650,000 marine mammals are killed a year as bycatch, and also overfishing has reduced fish populations 50 to 90%. Polar oceans are warming, so this has already altered whale migrations, reduced benthic prey populations, and caused declines in polar bears and seals. So introduction continued. IEC in red list right now says that 25% of marine species are threatened with extinction, so 32 species out of 128, but only 40% of these species have been categorized because, or 40% hasn't been categorized due to insufficient data. So 50% of all species are threatened by 2 or more human impacts, starting with pollution being the most pervasive, then fishing, invasive species development, hunting, sorry you can't see that, and climate change. So 3 objectives that were stated twice in the paper was to determine which marine mammal species are at greatest risk, why they are threatened, and identify the major geographic hotspots of extinction risk, and then compare them to our human activities. So methods, they compiled a species-level database consisting of 125 extant marine mammals. Stephanie talked about them all: pinnipeds, cetaceans, Sirenian polar bears, and 2 species of otters. And then they used the 2 predictor variables, intrinsic biological traits and extrinsic environmental variables. They classified the species as threatened or non-threatened due to their IUCN categories. And then they used random forest modeling. They also use ESRI's ArcGIS to calculate the special stats like the AMPP and the human impact. So the results, random forest modeling was 92% accurate in classifying the species on the red list. So they classified 27 out of the 32 species already on the red list, plus 15 more species. And out of those 15, 2 of them were on least concern, and 13 were data deficient. And so 37% of extant marine mammals are at risk of extinction right now. So they then decided that, or they found out that intrinsic rates, or intrinsic variables, are more important than extrinsic, and this is the picture of it. So intrinsic that Stephanie covered, body mass at weaning, number of births per year, taxonomic group, geographic range, social group size, adult body mass, habitat, and foraging location. Those are intrinsic, and we can see that most intrinsic are a lot more important than human impact and AMPP. And then the next thing I'm talking about is speed of life history. And so this is the rate of production, or the size of offspring at weaning multiplied by the frequency of breeding. So this is important to see how fast species recover after their threats have been removed. So example, the baleen whales, they have a fast life history. Gray whales, okay, so baleen and gray whales have fast life histories, and they showed a very strong recovery after the ban on commercial whaling. Also, sea otters and northern elephant seals, definitely northern elephant seals, they had a huge population bottleneck from hunting, but they increased tremendously after protection. And then another example of fast speed of life history is pinnipeds. So when they do have a fast speed of life history and they fail to rebound after protection, this means that either the threat was not removed or that new threats have occurred, such as global climate change. And an example of that, say like the tuna fisheries, when they made all these regulations, but their population stayed the same, it didn't increase, means that maybe the fishermen have been lying about their catches. So that's just an example of that. And then species with low productivities or slow life histories often belong to the same taxa. So two examples of this: the manatees, they have a very low productivity, and they're the only herbivores or herbivorous marine mammals, and they have a very small geographic range. And then toothed whales have low productivity, but this is offset because they have large social groups and they have a large geographic range. And then there's also multiple pathways to extinction, so risk usually cannot be linked to only a single intrinsic or extrinsic variable. So example of this is a monk seal. Although monk seals have high productivity, they have a very small geographic range in Hawaii, plus all the human impacts such as habitat loss and destruction, so they're critically endangered right now. So this is the map of the most at-risk species, and they correlate with the 13 hotspots on the coastline. So all the red is, I think I want to say it's 6, it's on our next slide. So yeah, these are the at-risk species, 11 right here, and then the open oceans are also good places for a hotspot because they have cold currents, upwelling, high productivity, and they support large populations of big marine mammals. And also coastal areas have high human impact. So this model indicated species that live, breed, and forage along coasts are at higher risk due to human impacts. So the next one is, it is the hot spots. There's 13 of them on here. So this one, East Aleutian, California, South Africa, Galapagos Island right there, Chile, Patagonia, Japan, West Aleutian, wow, this is fun. You can't even read this, can you? Indonesia, North Australia, West Australia, South Australia, and New Zealand. So those are the 13 hotspots. And 74% of marine mammal species experience high levels of human impact right now. So hotspots are defined as areas with 6 or more at-risk species. That's what I was looking for earlier. So this is the meat of this paper. Fishing, this is a fishing map, and basically it's saying that overfishing is greatest in the Indo-Pacific, Aleutian Islands, and Patagonia. So right here where this is red, high, over here, Aleutian. And so the next one, shipping and pollution. Shipping and pollution directly impact marine mammals by boat strikes, noise pollution, oil spills, chemical waste, and entanglement in fishing gear. And ingestion of plastic debris as well. So we see that it's high in California, and right here, California and Japanese, and then also this Atlantic Ocean, but it's really important here because these are major population areas for humans and shipping routes. Climate change is very widespread and escalating, and it's affecting more of the higher latitudes. And warming oceans are especially serious. Warming oceans are especially serious for polar bears, walruses, and several species of seals because they depend on the ice for feeding, breeding, and resting. So last one is marine protected areas, and the black are the hotspots that they identified in the paper, and the green, that you see speckled around everywhere, are marine protected areas, and right now there's only 0.7% of the ocean that is protected. And we also see that from this, only the Galapagos Islands is hotspots and MPAs are correlated. So we really need these regions of hotspots to become MPAs in the future. So conclusions, speed of life history was the most important predictor for extinction risk because it captures the capacity of a species to rebound from human impacts. The distribution of hotspots of at-risk species in relation to human impacts provides information that can be used to manage key areas for marine species or marine protection. And this analysis emphasizes the importance of understanding basic marine mammal biology and ecology in order to protect them in the future.
Thank you.